Hello everybody. Today's topic for 10.5 notes is operations with radicals. And I know we've looked at a couple of operations, so in our last session, talked about how to multiply and divide radicals. That's going to come back a little bit today, but we're going to start with the other two operations, which are addition and subtraction, and then the goal would be to put together the addition and subtraction with the multiplication and division that we've already seen. Okay? So adding and subtracting radicals, let me give you a little starter here, works just like adding variables. So for example, if I was going to be adding an x with, let's say, 5 more x's, well, the 1x that I have here plus the 5x's would give me 6x's altogether, right? Where when we go to add these like terms, we're adding our coefficients and the x part of it doesn't really change. Similarly, if we had like 2y and I wanted to maybe subtract 4y, well, the 2 minus the 4 would give me a negative 2 in front of my y. Or if I wanted to try to add, let's say, my 1x and 2y's, I wouldn't be able to add those because they're not like terms, so my answer would stay, okay, x plus 2y. Right? Well, radicals work the same way. If I had, let's say, 1 radical 2, and I wanted to add 5 more radical 2's, well, then I would have 6 radical 2's altogether. Where again, the radical 2 part isn't changing. All we're doing is combining the coefficients, so the 1 and the 5, to make the 6. Okay, so if we have like radicals, we can combine them by combining their coefficients in the same way we would combine the coefficients of like terms. And then similarly here, if we had, let's say, I don't know, a cube root of 4, let's say 2 cube roots of 4, and I wanted to subtract 4 cube roots of 4. Well, then I'm going to have a certain number of cube roots of 4 left, right? These are like radicals, so I combine their coefficients. The 2 minus the 4 would leave me a negative 2 in front of my cube root of 4. And then if I was trying to add, let's say, a square root of 2 and 2 cube roots of 4, well, those aren't like radicals, which means I wouldn't be able to combine them, and my answer would stay radical 2 and 2 cube roots of 4. So in order to add these, again, we're adding the coefficients, but we have to have like radicals, which means that the radicand has to match. If they don't, we can't add. And it also means that the index would have to match. And if they don't, we can't add. So I couldn't add a square root of 2 and a cube root of 2 because the indices wouldn't match, right? Or I couldn't add a square root of 2 with the square root of 3 because the radicands don't match. So I have to be able to add, I can only add, matching radicals and radicands and indices, and when we add them or subtract them, we are just dealing with the coefficients and not the radicands or indices themselves. Okay, so we want to make sure that all of our radicals are simplified before we attempt to add or subtract, and you'll see why in just a minute. And when we go to add or subtract, we add or subtract the like radicals. That means same index and radicand. Okay, we go to add or subtract the like radicals by combining their coefficients. Okay, we combine the coefficients, we combine the numbers in front of the radical. The actual radical, the index, the radicand, is not going to change. It will not change. Okay, so here, if I have 1 square root of 2 and I want to add 5 more square roots of 2, that would be 6 square roots of 2. Now, if you look at number 2, take a little bit of a jump. I definitely can't add these radicals as is. 27, 75, 3 are not the same, but hopefully you're recognizing that we can break some of these down. So 27, for instance, that's 3 times 9, and because 9 becomes 3 times 3, that means we could take a 3 out of that radical, and a 3 is left. So the radical 27 becomes 3 radical 3. 75 we can also simplify. 3 goes in 25 times. And that becomes 5 times 5, so a 5 comes out. Now it comes out with a 3, so that 5 times that 3 makes our coefficient of 15 here. And then we have a 3 left over, so 15 radical 3. And then good news, we don't have to simplify this, so that minus radical 3 comes down. And now we have 3 like radicals. They're all radical 3s, so we can put them all together by combining the coefficients. So if I have 3 radical 3s here, and I add 15 more, that's 18 radical 3s. Then I take this 1 away, so 18 minus 1 is going to leave me 17 of the radical 3s. Okay, And why I chose to box that one and not this one. All right, same thing here. Looks a little ugly with the cube roots, but it's the same process. We want to simplify. I can't break down a cube root of 4, so I'm going to leave that alone for a second, but 32 we can definitely break down. 2 goes into this 16 times. That becomes 2 times 8. That's 2 times 4, and 2 times 2. Since it's a cube root, I want a group of 3, and I've got one there. And that's going to multiply by the 2 that's already out there. So the cube root of 4 was just going to come down. This 2 times the 2 on the outside makes a negative 2 on the outside makes a negative 4. And then we have a cube root of 2 and 2 makes 4 left over. And then we're going to break down the 54. That's 2 and 27, which is 3 and 9, which means we could take a 3 out of this radical and we were going to have a 2 left over. So then we're going to be adding 3 cube roots of 2. Now the first 2 radicals are like radicals, so I can put them together, but I can't combine a cube root of 2 with a cube root of 4. So we're going to end up with 1 minus the 4. 1 minus the 4 is going to be negative 3 in front of the cube root of 4. And then I have plus a 3 cube root of 2 that I cannot combine. And that would be my final there. Okay? So I've got one for you to try. Feel free to pause and give it a shot. Otherwise, I'm going to keep working here. So we got 2 and 24. This is 2 and 6 and 2 and 3. So a 2 is going to come out and a 6 is going to be left. That 2 times that 2 makes a 4 in front of a radical 6. 96. That's 2 and 48. That's 2 and 24. That's 2 and 12. 2 and 6. And 2 and 3. So we could take out a 2. We could take out another 2, which would be 4. That 4 times that negative gives me a negative 4. And in front of a radical 6 again left over. And then fortunately don't have to break this last one down. So I'm just bringing down my plus radical 6. So if I have 4 radical 6's and I take 4 of them away, those 2 are going to cancel, which means all I have left is the 1 radical 6. So this is just 1 radical 6 for our answer. Okay? All right, number 4, same concept. I want to make sure everything is simplified and then see what we can combine. Now I know it looks worse with the variables, but remember the process is the same. 18 is 2 times 9. 9 is 3 times 3, so a 3 comes out. If I've got 3 x's in there, one of those can come out as well. So the 18x cubed becomes a 3x in front of a 2x's left over. And then the second one, I can't break down the 2x, so I'm just going to bring down 4x radical 2x. Now these are like radicals, so we can combine them by putting together the coefficients. When I combine 3x and 4x, I get 7x in front of my radical 2x. Okay, not so bad. I know it looks worse, but again, same process. Oof. All right, here we go. Same stuff. 8 becomes 2 times 4. And since that's 2 times 2, a 2 comes out of this. 2 gets multiplied by the x squared. So this becomes 2x squared. And in front of a square root of a 2, and that x is going to be trapped there. So 2x left over. And the next radical, I can't break down the 2, but if I have 3 x's, one of those comes out and gets multiplied by this. So 3x times x is going to give me a 3x squared in front of a radical 2 and x left. And then the last guy here, let's go pink. This is 2 and 25 and 5 and 5, so a 5 comes out. And then if I have 5 x's in there, 2 of those will come out. So there's a negative, a 5 comes out, an x and an x makes an x squared to come out, and then left over a 2 and an x. Okay, and now we've combined these by putting together the coefficients. So all radical 2x's, right? All like radicals. If I put together the coefficients, 2x squared and 3x squared makes 5x squared. But what's 5x squared minus 5x squared? Is 0. So we have a 0 in front of a radical 2x. But remember, that's multiplication, and 0 times anything is just 0. So everything cancels out, making our final answer 0. That's a lot of work for everything to go away. Okay? All right, cube root, or just means we're looking for groups of 3 now when we break this down. If you don't want to break down the 8, I probably wouldn't. Hopefully you don't need to. You should know the cube root of 8 is 2. But if you didn't see it, right, you're going to be able to take out a 2 with nothing left over in terms of numbers. And if you have 4 x's in there, one of those can come out. So you're taking out a 2 and an x, and left over in the cube root, you have just an x. Okay, here again, I wouldn't break down the 125. I know the cube root of 125 is 5, but if you're not seeing it, right, that's 5 times 25, and there it is again. There's your 5 that can come out. Now, if you only have an x in there, it's going to be stuck. So we've got a minus, a 5 comes out, and left over in the cube root is just an x. So now we have a different dilemma in this particular problem. We have like radicals, a cube root of x and a cube root of x match, but when I try to combine their coefficients, I can't combine a 2x and a minus 5. So one option is to leave your answer here. That would be a perfectly acceptable answer. Or because these two terms, the first term in blue and the second term in red, they have something in common, we could also factor in this problem. So we could say, if we factored out the radical x that they had in common, we could say that this is our cube root of x they have in common. If that factored out, what would be left would be the 2x and the minus 5. Okay, or we could just change the order we multiply and say this is the same thing as 2x minus 5 times a cube root of x. I don't really care which answer you had there. I think MATLAB would prefer the third version, but I'm perfectly happy with the green one that I boxed in, okay? So when you're combining the coefficients, they have to be like terms as well. All right, again, I have one here for you to try, so if you want to pause and give it a shot, go for it. All right, so 28 is 2 times 14, and that's 2 times 7, so a 2 is going to come out of this radical. Just one x is going to be stuck. So 2 times x gives me a 2x in front of a radical, 7x. Okay, 63. Let's see, 3 goes in 21 times, and then that's 3 times 7, so a 3 is going to come out. And I've got 3 x's, which means one of those comes out as well. So we've got a minus, a 3 and an x come out, and left over in the square root, a 7 and an x. So this one worked out a little bit better, like radicals and like coefficients, like terms for coefficients. So when we put these together, 2 minus 3 is going to leave me negative 1x in front of my radical, 7x. And there it is. Okay? So adding and subtracting, we're looking at simplifying and then combining the coefficients of like radicals. Now what we're going to do is try to combine these two operations with the two that we looked at last time. So in general, when we're combining operations, we want to follow our order of operations, right? Our parentheses, exponents, multiply, divide, add, and subtract. And then any rules that we've talked about applying to radicals, make sure we're sticking to those as well. We have to make sure in these processes that all of our denominators are rational and that our answers are simplified. Definitely not a big enough blank for that word. And then in this set of notes, we're going to see rationalizing binomial denominators, which we'll talk about how to do that in just a minute. All right, so let's look at number 7. Number 7, we're technically combining addition with multiplication, right? We're trying to add 3 plus a radical 5, and we're trying to multiply by a radical 2. Now, generally, we'd work inside the parentheses first, but we can't actually add a 3 and a radical 5 because those aren't like terms, which means we have to start with multiplication here. So we're going to distribute a radical 2, just like we would distribute anything else in front of the parentheses. So radical 2 times 3 is going to be 3 radical 2. Remember, this is outside, this is inside, those can't go together. And then we distribute here, a radical 2 times a radical 5 is going to be a positive radical 10. And then we try to simplify if we can, but I can't break down a 10, and those aren't like radicals, so I can't add, which means that's it. So sometimes it's that simple, okay? Now we're going to go from first gear to, I don't know, maybe fourth here. This is addition, subtraction, which can't actually happen because those aren't like terms in our parentheses, and multiplication. Since we can't add or subtract, we multiply first. So we're going to start here. 2 radical 3 times 4. Well, 2 times 4 is going to be 8 in front of that radical 3. And then, let's see, 2 radical 3 times 3 radical 3. The 2 times the 3 is going to give me 6. And then I have radical 3 times 3, which is going to make 9. And now let's distribute the negative 1 times 4 makes a negative 4. And lastly, negative 1 times 3 radical 3 makes a negative 3 in front of the radical 3. Now this can be simplified quite a bit here. Let's see. Red. So the radical 9 is just 3. So instead of 6 times radical 9, this is really just 6 times 3. which means this term really has a value of 18, okay? Now we also have some like radicals here. I have 8 radical 3's and negative 3 radical 3's. So 8 minus 3 is going to give me 5 radical 3's. Then I have another set of like terms, right? 18 and minus 4, those can go together. 18 minus 4 makes 14. So the two terms we have are 5 radical 3 and 14. Or if you had to rearrange that and put the 14 and then the 5 radical 3, that totally works. Doesn't matter the order you add, you still get the same answer. Just make sure you're not combining the 14 and the 5, since those are not like terms. That would be like trying to add 14 and 5x, right? Can't put those together, just like you can't put those together. Okay, so far, not so bad. Here, more multiplication. So radical 7 plus 4 squared. Remember what it means to square something. It means we have to multiply a radical 7 plus 4 by itself, by another radical 7 plus 4. And now it's the same process we just looked at. So radical 7 times radical 7 makes a radical 49. A radical 7 times 4 makes a 4 radical 7. Let's go peek here. This is going to give us another positive 4 radical 7. And then at the end here, 4 and 4 is going to give us a positive 16. So this radical 49 is just 7. And that 7 can be combined with that 16 to make 23. And then we have like radicals here as well. 4 radical 7s and 4 more radical 7s gives us 8 radical 7s. And again, don't try to combine those. In the same way you couldn't put together 23 and 8x, you can't put together 23 and 8 radical 7. So that's going to be our final answer on that guy. Okay? I got one for you to try here again. Feel free to pause and give it a shot. And these are conjugates. If you remember the rule, remember what happens when you multiply conjugates, feel free to skip some of the work. Radical 6 is going to give me a radical 36. And a radical 6 times a negative 5 gives me a negative 5 radical 6. And then here I'm going to get a positive 5 in front of my radical 6. And then at the end here, 5 times negative 5 makes a negative 25. Now this radical 36 is just 6. And I can combine the 6 here with the negative 25 here. And 6 minus 25 is going to give me a negative 19. And then what happens with a negative 5 radical 6 and a positive 5 radical 6 is they cancel. So all we're left with here is a negative 19. So remember what these are called, these binomials that match, right? They're called conjugates. That's when we have the same terms but opposite signs in the middle. And anytime we multiply conjugates, those middle terms are going to cancel. So when I said earlier, if you wanted to skip that work in the middle and just jump from the radical 36 to the negative 25 and combine, you'd be good there. Now if I took a binomial that had a radical in it and multiplied by its conjugate, what happened was the radicals canceled, right? And that's going to be a helpful process when we go to the next, or helpful thing to know when we get to the next problem. So here, it's putting together subtraction and division, but I can't divide 3 by radical 5 minus 2. But just like we saw in the other set of notes, we cannot leave that irrational in the bottom of the fraction. So we want to rationalize this denominator, and the goal is to get the radical out of the denominator. And so we're going to use its conjugate. Remember we did this the other day. If I had a 3 over just a radical 5, I said, well, let me multiply by a radical 5 and a radical 5, because that would give me a radical 25 in the bottom, and the square root of 25 is 5, right? That's the goal. Make a rational number here versus an irrational number in our denominator. Well, I can't just use a radical 5. I can't just use a single term to make this denominator rational. So what we're going to use is the conjugate. If I multiply the top and the bottom, remember, so that we're multiplying by 1 and not changing the value of the fraction, if I multiply by radical 5 plus 2 and radical 5 plus 2, what's going to happen on the bottom? Well, the radical 5 and radical 5 are going to give me a radical 25. And I know that the positive 2 radical 5 and negative 2 radical 5 are going to cancel. And then the negative 2 and positive 2 gives me a negative 4. Well, radical 25 is 5, and 5 minus 4 means our denominator is just a 1. That's a nice rational number. Okay, now we just got to figure out what's happening on the top. So 3 times radical 5 is 3 radical 5, and then 3 times 2 makes 6. And 3 radical 5 plus 6 divided by 1 is still 3 radical 5 plus 6. And that's that. And that's a simpler form than what we started with, okay? And one here for you to try, same process. Oh, let's go back and fill in the bullet points here. If we want to rationalize a binomial denominator, we're going to multiply. Okay, multiply the numerator and denominator. That way we're multiplying the fraction by 1. And what we're going to multiply by is the conjugate of the denominator. So remember, if we had something like a plus b in the bottom, a minus b would be its conjugate. All right, so we're going to keep the terms, just change the sign in the middle. So if you want to try this one out again, feel free to pause. We're going to multiply by the conjugate of our denominator. So same terms, 1 and radical 2, but change the sign. So 1 minus radical 2. So on the bottom of the fraction, what happens? Well, 1 times 1 is 1. A negative radical 2 and a positive radical 2 cancel. So I'm going to skip to this, which would be a negative radical 4. Well, radical 4 is 2, so this is just 1 minus 2, which means our denominator is really just a negative 1. Now on the top of the fraction, radical 7 times 1 is radical 7, and radical 7 times a negative radical 2 is a negative radical 14. So we have a radical 7 and a negative radical 14, and we can divide by 1, right? Divide this coefficient, or by negative 1. 1 divided by negative 1 is negative 1 in front of the radical 7, and the negative here makes a positive in front of the radical 14. And that would be that. Okay, now these both worked out to be 1s on the bottom of the fraction. That won't always be the case. Just, I guess, as a last little side note, let's say you did some multiplication and you had something like a radical 5 plus 2 all over, I don't know, 3 left over, then your answer would be stuck in that form because the 1 and the 2 aren't divisible by 3. Now, if you had, let's say, a 2 radical 5 plus 4 all divided by 6, 6 still doesn't divide into the 2 or to the 4, but if all 3 of these terms are reducible, then you would definitely reduce. So you would reduce by dividing each of them by 2. That would give you 1 in front of the radical 5, positive 2 here, and then 3 on the bottom. Okay, so you're going to see some variation in things that you might be able to simplify. And also recognize that this answer here is equivalent to radical 5 divided by 3 and positive 2 being divided by 3. So if you wanted to separate it into 2 separate fractions, that would be fine too. Now, I'm totally okay with you leaving the answer here, but you should recognize that these 2 versions are the same. Okay, let me get rid of this mess on my paper here. And that is it. All right, so this is a little bit of a shorter lesson. If we were in class, you would have had a quiz. But I'm not going to force that on you since we're in our suspension period.